Hello.
Oh, hi, can you hear me?
Yeah, I can hear you. How are you doing?
Good, how are you?
I'm good, thank you.
All right, well, just to get things started, I'm Robbie. It's good to meet you. Just to give you a little bit of an
Same
idea.
here.
Oh, go ahead.
Yeah. Yeah, so go ahead. Sorry.
Cool, so just to give you a little idea of how it's going to go, we don't really have a strict schedule, but I'm going to try to keep it to about 45 minutes, just so that we get a chance to kind of work in like a typical interview time frame. It is, of course, an anonymous
Okay.
interview, so if I ask you anything that you don't want to answer because you're afraid it might reveal your identity, feel free to just say so, and we can always move on. And we're just going to spend
All
most
right.
of the time working through some technical problems together. So for these, you can use any language that you want. I see you already found the syntax highlighting, so that's good. And at the end, I'm just going to try to stop you a little bit early, give you about 5 minutes to ask me any questions that you have. If that all sounds good, we'll go ahead
Okay.
and get started.
Yes, let's get started.
Okay, cool. So let's go ahead and start out with a little linked list problem. So I'm going to give you a linked list structure here. And I'm just going to write this as a basic struct. We don't need a whole class for this. So each node is just going to have a single integer for data. It's going to have a pointer to the next node in the list. So in that respect, it's a very basic singly linked list. We're also going to add one extra pointer to each node in this list. And we're going to call that the random pointer. So this is what's going to make our list a little bit different. And the random pointer is allowed to point to any other node in the same list. So it won't be null, it won't point outside of the list, but aside from that, it could point anywhere. So just to give you an example, I'm actually going to go to the Draw tab right now. If you look at the bottom left-hand side of the screen there, if you just want to go ahead and switch over to Draw, I will illustrate an example here. So imagine that we have an example list, and we'll say that it has nodes that we'll call 1, 2, and 3, right? The list is terminated by a null, so the next pointers just go from one to the next, totally normal, singly linked list. The random pointers, however, could go anywhere. So in this example, we'll say that the random pointer from 1 maybe goes over to 3. The random pointer from 2 maybe points to itself, and the random pointer from 3 maybe points back to 1, right? So these can be self-referential, they can have cycles, there's no particular rhyme or reason to them. So your goal is going to be to write a function which accepts the head node of one of these lists, and it's going to return a deep copy. So we want you to return the head node of a new list which has the same elements. So we'll call them 1 prime, 2 prime, and 3 prime for the new list. And this new list should have random pointers that mirror the structure of the random pointers in the original list. So 1 prime's random pointer would point to 3 prime, 2 primes would point to itself, and 3 primes would point back to 1. Does that all make sense to you?
I see. Yep. When you say one prime, actually the value remains same, the actual data, or even the data is changed. Data remains same, right?
I'm sorry, say that again?
So the one prime is the data remains same, right? Whatever the value of node one is the same value for the node one dash one prime.
Yes, that's correct.
Okay. All right. I see. Okay. What I'm thinking is, yeah, I think it's clear to me. What are we doing here?
Okay.
Uh, I'm trying to think like how can we solve this thing. Uh, I think the random pointers are a little tricky here. Next pointers are pretty easy
Hmm.
because for the next pointer, you go through the node one by one, create a next value, create a 2 prime and link 1 prime to 2 prime, keep going next, and keep creating the new values, prime values, and assign to the new node. So next is simple. The tricky part here is random. I'll say because when I create node 1 or 2, I don't have a node 3 coded. So where should my random pointer should point to? Uh, so what we can do is, I don't know. This is a very no. Probably not a good idea, but it's one of the approaches. Storing the address in a in a map. So I
Okay.
know that one point show this three, and I know for my three what is the corresponding three dash, and my one dash should point to the three dash. Uh,
Okay.
but it's like unnecessary wastage. Like for every node, I need to have a value on the map. Like one pointing to one dash, two pointing to two dash, three pointing to three dash. And when I want to
Hmm.
point from one to three, a random pointer, I will look at the value from the map, and my one dash will point to the three dash from that way.
Yeah, I think that sounds like a good approach.
Uh, yeah, the only thing which it is going to be a waste of memory because for every node we need to have an entry in a map.
Yeah, that's fine.
Uh, yeah. Uh,
Would you like to go ahead and get started on that?
yeah, I'm just thinking about there should be a better way of doing it. Uh, in which I need to store the map. I'm just think about that. Uh,
So I will tell you that there is a better way.
yeah.
Um, I've given
Okay.
this problem probably 2 dozen times. I think
Uh
one
huh.
person has come up with the better solution. So generally speaking, I don't expect people to find it, and I think that the hash map solution is actually very acceptable.
I see. I see. Okay. Okay. All right. Can I just take 5 more minutes to think about the problem before I go to the hash map? If I'm not able to come with an alternative approach, I will go with the hash map.
Sure.
Is that okay?
Yeah. Go ahead.
Um, so we cannot modify this nodes, right, to store any other data. It's fixed, right?
Um, no, you can modify them if you want.
Uh, Let me uh, uh, tell you what I was thinking. Okay, it's similar to map. What I was thinking, if my 1.21 dash, 2.22 dash, and 3.23 dash, what I would have done is with my extra pointer, which is pointing to 1 and 1 dash, 2 and 2 dash, 3 and 3 dash, I know that 1 goes to 3, and from 3 I can go to 3 dash. So my 1 dash can go to 3 dash directly. Um, I can explain the writing or drawing.
Yeah.
I was thinking something like this, but but the thing is, I need to modify this additional pointer I need to keep.
Oh, right.
So what
Yes.
I'm
So
saying is, once I predicted 1, 2, 3, 1 dash, 2 dash, 3 dash, I know I can go from 1 to 3. and from 3 to 3 dash. So I know my 1 dash should point to 3 dash.
Okay,
So
I
it's
see what you mean.
basically instead
Yes.
of a map, I'm directly just a pointer which is pointing to the copies.
Okay, so you are free to modify the data that gets passed in, but the actual structure of the nodes has to remain the same. So if we added an extra pointer, that would be basically equivalent to the map, right? If you wanted to reuse
Yeah.
the existing pointers, however, you are free to do that.
Or if I can use the existing pointers. Okay, so you're saying that it's it's not probably a right thing to do like this, right?
Right.
Are you able
Yeah.
to see my code?
Yes. Yeah. So
Okay,
we
that's
have to
not
keep this
acceptable. Okay.
right. So you have to keep the same two pointers, but you can do whatever you want with them.
I see. Okay. So if I cannot have this thing, what else I can have? Let's see. Let's see. So I cannot modify my random pointer because I need to know where I'm going. What if I modify my next pointer? What will happen here? How will I? Um, so another question is, shall I return the original list as it is?
So you just have to return the copied list. We'll say we don't care what condition you leave the original list in.
Okay, okay. If that's the case, what I'm thinking is, when I create one and one dash, and I create my next is two, so I modify my next to point to this one. So this will be broken like this,
Okay.
and my I create from, and this will point to this eventually, and this will be broken, and this will point to this eventually. So my original list next will be broken, but my randoms will be restored. Now how do I traverse the original one back? Because my randoms, I need to traverse the original list back for the random pointers.
You're very close. Um, so let's say that you do this thing that you're talking about, right? Um,
Mhm.
so so let's say that you do this, right? You now have a pointer from 2 to 2 prime. Okay. So do you still need 1 prime's next to point to 2 prime, or could you use it for something else?
No, it can be like this, and this points to prime.
Hmm.
If my one prime points to two, two points to two prime points to three, then probably I'm okay.
Yep. I think that would do it.
Just I need to do every time instead of a next. If I would go from one to two, I have to do next next.
Hmm. I think
Okay,
that looks like a good idea.
and uh, yeah, I hope it does not get complicated. But let's okay. I'll give it a try.
Okay.
Uh, let's say
Oh, you don't need a main. You can just write a function that accepts the input and returns the output list.
okay. Are we going to run this one?
No.
Uh, okay. Let's say note star or deep copy note star head. So if my head is null, then we just return head, whatever value you have. You don't have to do anything. Okay. Otherwise, what should we do? Let's make a copy. Note star uh base equals head, so that we never lose track of my base. Uh, and let's say I make it as temp some uh, or is it PTR. So while PTR not equal null pointer, we'll keep going this. Hmm. So what I'm doing here, uh, let's say um, my constructor is such that node it takes data and it copies data like this, and these are by default null.
Okay.
If not, I can do the make constructor also. So I will do one thing. Uh, Node star new base equals new node, which is with the base data, and so what I've done is I've created a new base. This is my original base. This is my new base, and pointer equals, and we have moved the pointer here. This is pointer one, and okay, and pointer two is this next. Okay, while pointer one next is not equal to null pointer, so this means my next is not null. So I have some data there. Uh, so I will create a new node star temp equals new node pointer one using data, and my pointer two next points to this new node temp, and my pointer two now moves to this temp, and pointer one equals pointer one next. So basically, it's just copying the whole list. So if my original list is one, two, three, I created a base, new base here. Uh, I copied it to one prime, two prime, and three prime like this. So I have done up till this much right now. Um, Now I need to modify the next so that one points to one dash. Um, Either I can do it in a separate routine in which I traverse the linked list again and making next point to the next one. I'll do it right now in the separate routine to just not confuse things. Maybe we can do it in this routine itself.
Okay.
This is optimization we can do, but well, right now I want to just avoid any kind of confusion to make it work, and then I will try to optimize it.
All right. Sounds
So
good.
my pointer one goes to base again, and my pointer two is again to the new base, and while pointer one note star temp one equals pointer one next. So which means my temp one will be two. So this is node number two, and my pointer one next is equals pointer two. So now pointer one was one. So one next points to one dash. Uh, Now my pointer one becomes temp one, so it becomes two, and my pointer two advances ahead. Okay, so what I've done is I have changed the mapping into something like this.
Okay.
Pointer one equal to base, pointer two equal to new base, pointer one next is not null, that's true, temp equals pointer one next, pointer one next equal to pointer two, pointer one equal to temp one. Yeah, okay. Now what I need to do is I need to traverse the original list again, and now I need to change the random pointers.
Okay.
Actually, fill the random pointers for this one. So what I'll do is, okay, let's do the setting again. Okay, now what I'm doing here. Now I'm thinking now what I have done can be done could have done the other way, which would have been if my one dash pointed to one, I could have done that one dash random is one dash next, which is once random.
Mhm.
Or this is also okay. What I will do is now pointer once next. The pointer one there will always be a next for the pointer one, which is give me one prime, and its random is nothing but pointer once random.
So pointer one's random. It's going to point to a node in the original list, right?
Yeah, that's right. So pointer one randoms next. So pointer one next random is pointer one random next. The trouble I'm having now is how to advance pointer one ahead. Uh, what I'm struggling right now is I cannot go from one to two, right? Because I
Hmm.
have broken the next one. So had I done, hmm,
So right now, one prime's next is two prime, and two prime's next is three prime. Um,
yeah.
do you necessarily need those next pointers in place, or could you use them for something else?
Uh, you know what I could have done? So for one prime or two prime, this mapping, their random are right now nothing. They are bogus. So if I had done the other way, one dash pointing to one, I could have done my one dash random is one, two dash random is two, and now what I would have done could have done is I could have traversed this whole node. My random would have given me this one, and from this random I could have gotten the value.
Okay. Think so. The problem there is that we're going to want to write to the randoms, right? What if one prime's next pointed to two?
Let's see what did we thought about this. Oh, that's what we just thought, right? This goes here and this is going here.
Hmm.
Yeah. That is also going to, yeah, I think that will also work. I need some code changes here. So my temp one is pointer one's next. Sorry, it is two initially. Let's go back to the original diagram. So I have something like this. Um, what I want is my temp one is this. Temp two is pointer two next, which is two prime. My pointer one next is pointer 2. My pointer 2's next is temp 1. So this will give me 1 dash pointing to 2. My pointer 1 is temp 1, which is 2, and my pointer 2 is temp 2, which is 2 dash 2 prime. Uh, I will just go through this again. Maybe I'm missing some case. And I should do this while pointer 1. Yeah. So what will happen here? My pointer 1 points to, let me write it down somewhere. Pointer 1, pointer 2. I'm just noting down all the variables and see how the values will change.
Okay.
So my pointer 1 initially points to 1, pointer 2 points to 1 prime. My temp 1, pointer 1 is not equal to null, so my point temp 1 will be pointer 1's next, which is 1's next 2, and temp 2 will be 1 2 next 2 prime. Initially the state is like this. Now what I do is my pointer 1 next points to pointer 2, so this next is gone, and this happened here. And pointer 2's next points to temp 1, which is 2. Pointer 2 next, pointer 2 is 1 dash and 2 is this. So we have something like this. And since I'm changing the next, this will go away. My pointer 1 is temp 1 now, and my pointer 2 is temp 2, which is 2 to prime. And now we go ahead and 2 points to 3. Pointer temp 2 will be pointer 2 is next, 2 dash, which is 3 dash. Yeah, it looks fine to me.
Okay.
Now, uh, yeah. So pointer 1 next is nothing but pointer 2, 2 points to prime, and this is, and 2 goes to this, 3. Uh, what's happening here? And 2 prime goes to pointer 2's, 2 temp 1, which is 3, which is also right. I just want to make sure this part is correct because this is the key here.
Okay.
Now my temp 1 is pointer 1's next. Sorry, becomes 3. This becomes 3 prime. My temp 1 is null pointer. Temp 2 is also null pointer. Pointer 1's next is pointer 2, which is correct. And pointer 2's next is null pointer, which is correct. And pointer 1 becomes temp null null. So this is fine. Yeah. This will become null. And this will become null too. And we exit from the loop. So we'll have this linked list ready. And now if I have to traverse here, I go to the pointer 1 base, pointer 2 new base, while pointer 1 is not equals to pointer 1 next random is nothing but pointer 1. Okay, now pointer 1's next random is nothing but pointer 1's random next, correct? And I advance the pointer 1 now with uh, next. Okay, except the last case where there is no next. I should be careful here.
So pointer one will always point to a node in the original list, right?
Right. So pointer 1 is 1 here, and
Mhm.
it from 1 it goes next to 2, to next to 3. But if I do a next, there's nothing. So
So, so the
if
next
pointer
from three, I mean, so three has a next, right, which is three prime, and then you can take the next
right
of that, which is just null.
next. Oh yeah, that's correct. Which is null. So pointer 1 is 3, its next is 3 dash, and its next is null, so it should be fine.
Okay.
And I will return the. Oh, I need to correct the pointers again so that original list is back, but I have to return in the end new base.
Right.
But I need to fix the pointers because the next are wrong. Uh, so let's do this activity again. So okay, so in this case, both the original list and the new list will be fine intact, which I was worried about initially that I will the first linked list will be destroyed, like uh, it will be wrong state when I leave it, but no, we can fix that too. So probably what I want to do is two and two dash pointer two's next. So temp. So my pointer one next is equals. Sorry, this is wrong. My temp one is pointer one next, which is one prime, and my pointer two is new base, which is one, which is two. So my pointer one next is equals temp two, and my pointer two's next is temp two next. So temp one is this. Uh,
Alrighty.
pointer one, pointer two, temp one, temp two. So pointer one is one, pointer two is new base one prime, temp one is pointer one's next, which is one prime, and temp two is pointer two's next. Pointer two's next one, two. So what I'm doing here is now pointer one next is not this anymore, but it is temp two, this one. And my pointer two, which was one, its next is nothing but temp two next, which is two prime. Okay, my pointer one is nothing but pointer one's next, because we have already the right pointer. From one we can move to this, and pointer two. I think I could have done this with just one pointer, because it's going zigzag. I could have done it with one pointer, but
That's okay. It's a first try. I think that looks pretty much good. And we're also kind of coming up on the end of our time here. So at this point, I will stop you
yeah.
and be glad to answer any questions you have.
Um. So I was not sure like about had I gone with the hash one, would have been acceptable, or would there have been some negative points for that?
Yeah. So when I use this for real, I just expect people to do the hash solution. Um, I have only
Okay.
had, I think, one person ever come up with this approach before. So, a very good job coming up with it. Obviously, if it was a real interview, I wouldn't recommend like going straight for the optimal one, right? Like, it's always helps to just get something that works down first and then optimize from there. But for just an exercise, that was very well done.
Okay. Okay. And so like one thing which I'm not sure is, when do we decide that okay, it's time to spend some more time with the optimal one, go for the optimal one? Like what might happen is I could have started coding the hash one method, and later on I have realized,
Hmm.
oh, I could have done this way, but at that time, no, there was not enough time left to write the code.
Yeah.
So
So
and any addition on that side?
I mean, the big thing is always just communicate with the interviewer, and usually they'll give you an idea of what they want. Generally speaking, you're going to
Okay.
want to go for kind of a basic solution first. So there are problems that I give where there are more optimal versions that I expect. But when I give those problems, generally I have them kind of timed out in my head. So there's like a progression that I'm expecting, right? Like they'll probably do this basic version first, and then I'm going to prompt them to see if they can do this optimization. So, generally with those, like if I have multiple versions of a problem in mind, I also make sure that there's time in the interview to do those multiple versions.
Okay. Okay. That makes sense. Yeah. That's all I have uh, questions
All
to
right.
ask. Thank you so much.
Yeah. Thank you. Thank you for your time, and I hope you have a great rest of your day.
Uh, you too, and thank you so much for taking time to interview me. It helped me a lot. I'm real thankful to you for that.
Awesome. Well, have a great day. Thank you.
You too. Bye bye.
Bye.